anytime before midnight tonight, I will count you as having it in on time. So if you haven't done that already, please do that. Yeah?
When you say, like, for assignments due on Tuesday, are you talking at the beginning of class, by the end of the day?
By the end of the day is fine. Like, if you get it to me, like a paper assignment, if you get it to me by the time I leave, that's fine.
Okay.
And I'm here anywhere between 4 and 4:30. So.
Wow.
Okay. All right. So today we're talking about intervals and end behavior. Is it still making noise?
Yeah, it's like staticky.
Awesome. So, well, between that and the machinery out there, it's going to be a noise-filled day. Okay. So, part of what we're going to be talking about, like I said, is looking at those key features from your parent function worksheet, how those change when we start moving stuff around. So, we're going to start with our good old friend, the quadratic function. We'll say we've got some function f of x equal to x squared. And I'm going to change this so that it is translated from the original. So I'm going to change it to some new function. I'll call it g of x, which is going to be x minus 3 quantity squared plus 5. Now, as far as what we learned yesterday, changing this from the original, Tayden, is it going to be shifted up, down, left, or right?
Up.
Up how many?
5.
Great. And then left or right?
Left.
It's the opposite of what you think it should
right.
be. So it's going to be right 3. So even though this is a minus, you think it should be left, it's going to be the opposite. This is exactly what you think it is. So like this plus 5, up 5. This minus 3, the minus is going to, like, it's in the parentheses with the x, so it's going to be the opposite, and it's right 3. Kind of, sort of? Cool. So that's what we were talking about yesterday. Today we're going to look at kind of those key feature things. And if you're looking at that basic functions sheet I gave you last week, we pull that out and take a look at our good old friend, the quadratic equation, parabola. I want to focus on things that are going to change with the domain and with the range. So the domain of the original function was x such that, yeah, I wrote it this way, x is real. So any real number works for the domain. Now, shifting it right 3, is that going to do anything to restrict the domain or to change the domain from what it originally was? No, because like what's happening, like I had my original parabola, which was centered, which had a vertex on the origin. I moved that parabola 3 units to the right and 5 units up, so it's here now. But it's still going to be able to touch every possible x value. It's just like it's going to keep going on both sides. So the domain is going to be the same. It's going to continue to be x such that x is real. So the domain is unchanged. Okay? The next thing that we talked about with the original quadratic is the range. The original quadratic had a range of y such that y is greater than or equal to 0. Well, this is going to be changed by the fact that I moved it up 5.
So the y is such that y is equal to or greater than 5?
Yeah. So that moving it up 5 moved it from being y greater than or equal to 0 to y greater than or equal to 0 plus 5. Does that make any sense? Kind of, sort of? Okay. So domain and range, we've got y such that y is greater than or equal to 0 on the parent graph. But by moving it up 5, we moved that up 5 as well. All right. Now, how about things like the x and the y-intercepts? So X-Intercept and Y-Intercept. This gets a little weirder. Okay, so the X-Intercept of the parent function is 0, 0, and the Y-Intercept of the parent function was 0, 0. We talked about that in class last week, right? Now, if I move it so that it's actually, maybe it'd be better if you actually saw this using your calculator. So how about we do that? All right. So, and then also just to kind of review how you graph stuff. turn on the calculator, bring it to the y equals menu. I'm going to clear out anything that was there. Can you guys see my calculator okay? I know it's glared right now. Okay. All right. So I just went to the y equals menu, and again, I checked to make sure that you haven't gotten one yet. 7222 is yours. All right. Yeah. No, that's not going to happen. That's like doing hard mode. Okay. So I'm going to type in the function I had right here, which is in parentheses, not comma, parentheses, x minus 3, close parentheses, squared, and then plus 5. Yours might look slightly different when I'm entering this because we have a bunch of different versions of the TI-84, but it's going to do the exact same thing so long as you're typing it in as x minus 3 in parentheses squared plus 5. All right. If it's a calculator that you haven't used in a while, like if you haven't graphed in a while in your calculator, before you graph it, you always want to hit zoom. And then you can either arrow down to 6 and push enter, or you can just push 6 on the number key, or on the number pad. And then give it a second to graph because it's a little slow. All right. Now, looking at the way that this function looks, is it going to have an X-intercept? No. Because we moved it up, like, it is never going to touch the x-axis. So as far as x-intercepts go, the x-intercept goes from being at 0, 0 to none. Okay. Now, as far as the y-intercept goes, you can't quite see on the calculator where it's going to cross the y-axis. So the easiest thing to do to find the y-intercept is to use the table function that your calculator has. And to bring that up, you're going to hit second first because table's in blue. So you're going to hit second graph to bring up table. Now the y-intercept is the y value when x is 0. So if I go down to 0 on x, the y value is 14. So that means the y-intercept is the point 0, 14. Does that make sense how I just did that? Okay. The other way you could have done it without using a calculator is you could have taken this original function and plugged 0 in for x, and then you would have been able to find out what the y-intercept is, because whatever value the function has when x is 0, that's the y-intercept. So both of those would have been fine. So if you put 0 in for x, you'd have negative 3 squared, which is 9. 9 plus 5 is 14. Right? Okay, cool. So now, we're going to talk about two more things here that I hadn't added to your sheet. So bear with me on this. We're going to talk about something called end behavior. And what end behavior means is it's what's happening to the function as you go really positive or as you go really negative. So on the original function, as you're going farther and farther to the right, is the function going up or is the function going down? Up. So the end behavior of the parent function, I'm going to write it as this. I'm going to write it as x, and then this arrow that in math means tends towards. What is a name for a really, really, really big positive number? Like the biggest positive number you ever thought of, and then a number bigger than that. What's the name? Okay.
Positive infinity?
Yeah, so as x goes to infinity, which is this sideways 8, y is going to go to, so as you're going really far to the right, the function, well, is the function going up or is the function going down?
Up.
It's going up. Up is also known as infinity. Maybe even a little glimmer of it making sense? Okay. Now, the other, like, all functions are going to have two end behaviors. This one has as x goes to infinity, y goes to infinity. And then we're going to look at what happens as x goes to super negative numbers. And that's going to be called negative infinity. Did you guys know before today that there's more than one infinity?
Yeah.
Yeah, there's There are more than, there's many infinities. In fact,
isn't there infinities to powers?
yeah, but like, okay, neither here nor there. Okay, so,
I thought that was a thing.
no, it is. As you're going farther and farther to the left, as you're going more and more negative, is the function going up or is the function going down? Okay, so as x tends to negative infinity, y is going to tend to positive infinity again. Now, this is the parent function. If I changed it to move it right 3 and up 5, have I changed that end behavior at all? Have I made it so that it is no longer going to positive infinity as x goes to positive infinity? No, I've done nothing to change the end behavior. The arrows, like one way that you can think of end behavior is which way do the arrows point? The arrows on the ends of this parabola are still pointing up. And so the end behavior would be the same. As x tends to infinity, y tends to infinity. As x tends to negative infinity, y tends to positive infinity. Okay. Is there a glimmer of that making any kind of sense?
So the only time it changes is when you put a negative and like flip the arrows the other direction.
Yeah. Yeah. Exactly, James. Good. So, like, let's take a look at exactly what that would be, though. I'm going to use a different function since I feel like I've picked on the quadratic quite a bit. So, just taking a look at your basic functions here, I'm going to look at, let's say, the cubic here. This, Mr. Shaft. Yep. Mm-hmm. Tori, you are needed in the office with your things. Okay, so I'm going to look at the cubic function here for a couple different reasons. One, because this has kind of interesting end behavior. But let's say that we have a parent function that is, call it f of x is x cubed. And our new function is g of x, which is negative 2 times x cubed. No pluses or minuses anywhere, just negative 2 times it. Okay. Now, for the domain and range, nothing is going to change the domain and range on this, and the reason why is the domain of the original function was both like x such that x is real and y such that y is real. If I am multiplying it by negative 2, that means that I'm doing a couple things. First, I'm reflecting it over the x-axis so that rather than going from the left to the right going up, it's going to go from the left to the right down in the same kind of behavior. And then I'm stretching it by a factor of 2. Does that make any sense? No. Okay. So nothing I did is going to change the fact that the domain and range is unrestricted. The domain and range is every possible real number. Okay, you guys with me so far? All right. So I'm not going to go through that. I am going to talk about end behavior on this, though. So end behavior. All right. On the original parent function, if I'm looking at this one here, as x goes to something super big, what happens to the function itself? Is it going up or is it going down?
It's going up.
Okay.
If you are a student athlete and you are in fall sports right now, you have to be drug tested today. Please do not use the restroom if you need to. If you need to go right now, go out to the shop. We're at in the shop. Just go out to the shop and Karen will let you know.
Like, so shop restroom, right? Like not just, okay, never mind. No, but I mean like, if you need to, never mind. Okay, never mind. All right. Okay, so as x goes to infinity, y goes up.
If you're an athlete in the fall sports,
We need grip.
if you're an athlete in fall sports or we drug tested today, please don't go to the bathroom. If you need to go to the bathroom, go to the shop and Karen will get you set up.
The way that he said it though is way more ominous. Anyway, okay. Yeah. Okay. That's what I was thinking, but we're gonna stop that right there. Okay. All right. Okay. Back to end behavior. So if we're looking at what happens when x goes to the left, to the super negative numbers, so like as x goes to negative infinity, the parent function, is the parent function going up or down as you're going to the left?
Down.
It's going down, right? Super down, like way, way down. So as x goes to negative infinity, y is going to go to negative infinity as well.
If you're in false court.
Right. Okay, so this is the end behavior of the parent function in this case. You guys with me so far? All right. Now if I go to our super duper math helper machine, I'm going to clear this out again, and I'm going to type in the g of x that I chose, which is negative 2 x to the third power. And if you need to do to the third power and don't know how, you're going to use this button right here, right below clear. It looks like an arrow without the stick. It's called a caret. It's how you do exponents in this calculator that aren't squares. So negative 2 and then x to the third. Okay. Now to graph it, I just used it, so I don't have to do zoom 6, but you can if you want to. To graph it, I'm just going to push the graph button, and then that's the function that comes through. So now this one, if we're taking a look at its end behavior, if I want to see, I want to put this on the same line. If I,
just reverse?
kinda. I want to know what you mean by reverse though. So like as x goes to infinity,
It's negative.
y goes to negative infinity.
And then the other one would be positive infinity.
As x goes to negative infinity, y goes to positive infinity. Right?
Not exactly what I was thinking.
Yeah, see, that's what I meant by, I wanted to know what you meant by reverse, because these don't change. It's these that do. These switch. You're still looking at what happens as x goes to positive, because if you reverse them both, it's the same. Negative times negative is the same,
Yeah.
right? Okay. All right. So I'm going to give you an assignment. This assignment is going to last probably today and a little bit of tomorrow. So tomorrow I'm going to do something in class and you guys have another assignment. Part of this you're not going to do right away, because I want to leave the increasing and decreasing intervals for later, because I feel like this is enough, like, I don't know.
Frame interfaces.
Well, and it's really not
It's been the summer and our brains are kind of fried.
So I want to show you which parts I want you to do for now, and then tomorrow we'll revisit this and do different parts. So for today, all right, so for today, I want you guys to be taking a look at A, B, C, D, and G. Well, actually, no, you can do F and G. So I want you to be looking at every part except for E. E ends up actually being the hardest part of this assignment. So, for example, going through here, question, or the first example, like it's already done for you. Like we have this is the function, negative absolute value of x minus 1. A, the parent function, is absolute value of x. Or you could just write absolute value function if you don't want to write the equation. Or you can write the equation if you don't want to write the words. Up to you. What's going to happen? It's going to be shifted down 1. So you don't have to write like this whole sentence like this. You could just write down 1 and then reflect it over x-axis. And that would be enough. It doesn't have to be a complete sentence. The graph is right here. The domain is going to be all real numbers. And the range in this case is going to be y is less than or equal to negative 1. Because that's the only place where the function exists for y. Does that make sense? Okay. Don't worry about increasing and decreasing. The x-intercept, nowhere does it touch the x-axis, so there's no x-intercept. And the y-intercept is 0, negative 1. And then the end behavior is as x goes to infinity, as you're going to the right on the graph, the function is going down. So as x goes to positive infinity, y goes to negative infinity. And then in the other direction, as x goes to negative infinity, y goes to negative infinity as well. Okay.
Alright, so now it makes sense.
That makes sense.
So like when you're looking at question number 1, part A is asking you to tell what the parent function is. Parent function would be y equals absolute value x, or you could just write absolute value function. That's fine. Part B, how has it been changed from the original? So up or down at all? Down 4. And then it hasn't been moved left or right because there's nothing with the x,
Reflected over the x-axis.
but it's been reflected over the x-axis. Reflected over x-axis. Over x-axis. Okay, now if you want to be able to graph the absolute value function in your calculator, here's how you can do that. You would, in this case, I'm going to go back to y equals, I'm going to clear it out. And I'm going to type the negative first for the negative that was there. And then to do absolute value.
There's not much on this graph.
Okay. To do absolute value, you're going to hit the math button. Arrow over to NUM for number. And the first option is ABS, open parentheses. So, hint, ABS doesn't stand for anti-lock brake system.
Stands for abs.
Yes, yes. This is how you get a 6-pack. Okay, the calculator is going to do absolute value, and then when you hit that button, it automatically creates the absolute value things. Or if you have one of the older ones, it'll just say ABS and then open parentheses. It means the same thing. And then I'll do X. And remember when you're doing this graphing, you're going to use this as your X button. Going to arrow over so I'm outside of the absolute values, and then -4. I just used it, so I don't need to do zoom 6, but you can if you want to. And then graph it. That's what it looks like as a graph. But if you want to be able to translate that graph onto points on here, second table, you can move around. You're only graphing the points that actually fit. So as Kim pointed out earlier, not very much of the graph fits on there. Kind of, sort of, does that make sense? Okay, so that's graphing. Domain and range. Domain is unrestricted. It's x such that x is real. And then the range, just like the one before, is going to be y such that y is less than or equal to -4. Awesome. Okay.
Very distracting.
All right.
High tech here.
You guys can work together if you want to. You can work alone if you prefer. I'll come around to help anybody who needs help. And then Dylan, I just realized you probably don't have this handout, do you? Since you just joined us yesterday. So come grab it.
This one, the basic function.
Oh, you do have it.
Yeah, I was here second day.
Were you?
Yeah,
For some reason, I thought you started yesterday. I'm out of my
been
mind.
here since the second day.
Okay, I'm out of my mind.
Had a good fish out.
Mm-hmm.
Thanks.
Mm-hmm.
That's a lot of work.
Okay, if you're against convenience, that's
Let 'em on it.
You're against convenience.
both of you could move to where there are 2 desks together. Like, there are multiple solutions to this problem.
Problem solved, right here.
Okay, great, go for it. Yeah. We're not going with that today. So you're doing every part but
That's
mm-hmm. So like you're doing X-Intercept and Y-Intercept. Everything? Is X is positive, right? Or does this function go up? So then Y is going to E. And then
Is that a
X
test?
is negative, then Y goes
Alright.
It won't always be the same. Like I showed you on that one example. Sometimes it's different. Yeah, it looks like it's more work than it is. Because like it's really only
I know.
yeah, and a lot of white space. Like all this space is just to identify the parent part. So it's really not that bad. saving that for tomorrow. We're not going to talk about the increasing and decreasing yet, because that's like, I think that's more confusing than we've already covered. So you're doing everything but E on the packet.
So the Y-intercept would be -4, right?
0, -4, write it as a point. And then what's the X-intercept on that one?
That's
So then just put none. Make sense?
yeah.
So then just put that it doesn't, or like why doesn't it do anything there? So the domain of the parent function here is x such that x is greater than 0. You've moved it left 1. So instead of being greater than 0, it should be. Okay, so the domain is x such that x is greater than -1. And then you didn't move it up or down. The range is the same. It stretches it further, like it makes it longer words. And then it compresses it. Yes. Exactly. When space down too, so it's that situation where you've got that screen is broken.
Is your phone already cracked up?
Yeah.
I think practice history is wrong.
It's actually pretty good there.
It's like right underneath your right phone.
It is cracked a bit on your phone.
It's right on its screen.
Well, it is both cracked and not cracked. It's Schrodinger's phone. It's both cracked and not cracked until you shut it. So you could argue that if it were cracked, the act of turning it over is what cracked it.
Oh. Are we really only more loud? That's deep.
I remember reading about Schrodinger's cat and it just made me trip out.
It is a way of explaining something that is very strange about atoms. That's why it exists. Mm-hmm. Yeah, and so like as x goes to negative infinity, you can just write like y is not
So on page G, like 3, would it only just be as x goes past infinity, y goes to infinity?
You want to add that it doesn't exist as x goes to negative infinity, so you would write something like as x goes to negative infinity, y does not exist.
Alright.
Okay? Because it is a what's called a one-sided function.
That was actually really bad.
No, that was okay.
Y does not exist.
For this function, I don't even have to put in the string.
Is it for all negatives? For every single negative? Try -1.
there's no number I think that is
Or like, so if you have negative 5, you're going to try to solve for x.
You gotta
You
look
wouldn't
at
be able to
the
do it really as up there.
Yeah, you gotta look at the
Really nice one, circle, circle.
I would just, it does radicals.
It does radicals and it does fractions very easily.
Then it simplify radicals.
I know. You sure?
I got it for my birthday.
Great. Awesome.
Okay, besides robot
Robot TRX is using you'll have to, and easy to find on here, like the Y-intercept is in X and 0, and the X-intercept is in Y and 0. So 3 and 7. So even if like, if you didn't add the extra parts to the graph, you could still find that the X-intercept would be 3 and 7 because that's what Y is. Oh, sorry, Aaron.
So it's inside of the radical that created like this triangle. So that's still moving up.
Yep. So moving up one line. So we're outside the radical, that would be upper zero.
Yeah.
Yep. Yeah. And one way you can do that is to go here, table. The Y-intercept is what Y is when X is 0. The X-intercept is when Y is 0. So like negative 1, 0 is an X-intercept. And then the other X-intercept is right there. 5, 0. Oh, is this one right 3 or down 3? Down 3. Well, it's actually both at the same time. So you could count it as being down 3, but because it's a line, you could also count it as being right 3. So you could put just the same. It's the same. So if down 3 is what you want to go with, down 3. And with that is like the one exception where it doesn't matter. Just to remind you guys, don't forget to do Google Classroom. If you're having trouble with that, please come see me like during time to teach or after school or whenever. And then the assignments from last week. Homework number 1 in the broken calculator. That was even quieter.
They don't know how to count very well.
No, if you're done, you can hand it in. I'll hand it back to you tomorrow when we talk about part B. So I know if it were me, I have trouble holding on to papers. I want to have it somewhere.
Making progress.
Will you help me with the focus stuff? So like understand what's actually going through now?
Yeah. I figured, I gotta go through like a page and through definition that's
I think that would be a good
Wait, it was two of these.
Karen Womack, will you please call the office? Karen Womack?
Yeah, you have to do part G. It's E that you don't have to do today.
what?
It's E that you don't have to do today.
Okay.
We'll go over E tomorrow.
Okay, what's the other? You had in your
like exhausted.
Like I do any classical like calculation.
So,
I got that one.
I'll give you one that I didn't write on. We're doing parts A through G, but not A. So you're like stating the quadratic function, describing the transformation, graphing it, and then the end behavior. Like if you don't understand that, we'll go over it tomorrow.
Okay, thank you.
Corey, you need to beat up Brett.
People around. They don't like you, Austin.
Brett, nobody likes you.
Nobody likes you.
Nobody likes you.
That's my friend.
Hey,
Oh.
it's me.
Hey,
Billboard is my friend.
Shut up.
yeah.
Shut up.
Shut up, you Hey, put some clothes on. Nobody wants to see those legs.
Everybody wants to see them legs.
Everyone wants to see that those are grow up.
Gunner is my best friend.
Only because you pay him.
Actually, I brought him cookies today.
Yeah, and see?
Because we're best friends.
See, Gunner, I don't have to pay you or you give anything. I just do it for free. See? It's not like that. Hey, but
He's gonna punch you because he hates you. Don't touch Timber either. She doesn't like you. Timber, tell me get off you. Tell me
get
get
off
out
the
of you.
rag, okay?
She says to get
Just
out
get
of
off the rag.
She says to get out
Shut
of
up.
Brett,
Yeah.
no.
Okay. Where's Robbie today?
Yeah.
If Robbie's gone, I'm seriously gonna get upset.
That's not
Nobody likes me. So
Nobody likes you.
the rest of it is you just fall first. I need to go to my locker. I forgot my binder.
Okay, so 3 questions for the warm-up today. The first was trivia, and then the answer we'll talk about in a minute. Triskaidekaphobia is how you say that word. And then the second one is evaluating using Pemdas, so parentheses, exponents, multiplication and division, addition and subtraction.
Do you have a need for a calculator, Caddy?
Yeah, sure.
I have one in here, but no calculators.
No, I'll take it. Thanks. Sweet. And then the last one, you're telling to which number system does it belong. So your answer is going to be something like, it might be an irrational and a real, or a real and irrational, or something like that.